Welcome, everybody. Appreciate you're here. Hopefully everybody's had a chance to grab you some lunch. We appreciate Big Daddy's catering our lunch today, and we appreciate them. They kind of, not pinch hit for me, but I was kind of absent-minded and got a hold of them a little bit later than I should have, but they came through in a pinch for me and got us a meal all taken care of, so you didn't have to eat a peanut butter and jelly sandwich. So we appreciate them. My name is Brady Blackett. I'm with Renaissance Ag, and we just want to, first of all, say thank you to all of you that have taken some time out of your day to be here with us for this Lunch and Learn. We've got some great information in store for you today, and we'd also like to thank our guest that's here with us today from Redmond Agriculture. We appreciate them participating with us as well in this. So we look forward to getting to know all of you guys. What we'll do, kind of how we'll proceed is we'll go through our presentation. If you have a burning question that you're just dying to ask during the presentation, go ahead and shout it out. Otherwise, we'll try and go through the presentation and get through all the material. And then we'll turn some time over to Aaron with Redmond, and he's got a few slides that he wants to share. And then we'll open it up for Q&A. If after the presentation, if you've got to take off, we understand. If you want to stay longer after the Q&A, you can stay longer. We're here to answer all of your questions and make sure that we get you the information that you need. So with that being said, we'll go ahead and get started. So this is asking a lot of me to use both of my hands at the same time to run a mic and this little clicker. I'm not the most technologically advanced guy. But today's presentation is going to be on the true value of fodder or sprouted microgreens. Just a couple of things we're going to cover here today. I'm going to tell you a little bit about us as a company. We'll introduce what we foresee as a problem in agriculture and what our solution is. Then we're going to hear from some of our guest speakers here today that I'll introduce to you in just a minute. They'll talk about why we sprout feeds, the benefits, and a little bit about our company and where we're going. So, Renaissance Ag, we're a relatively new company. We've been around for just under 2 years, and we have a goal to be a foundational partner with the small to mid-size producer in agriculture, whether that's feeding beef cattle, dairy cattle, sheep, pigs, horses, you name it. We want to be a foundational partner in your production. We want to help you to create a more viable, reliable feed source that's there, available for you, whether it's a drought like we're experiencing right now or whether we're getting adequate moisture and able to take care of ourselves from a water perspective. So, like I said, our mission is food security. That's big to us. We have a much broader mission than just fodder systems and being able to provide you with the ability to grow your own feed on demand. Being able to tap into the local supply chain and connect you with consumers is a big thing to us. We've also got some things in the works as far as being able to recycle some of the waste products that come from our operations. I'm a third-generation cattle producer myself, and so I feel a lot of what you guys all feel as well when it comes to some of the things that keep us from being successful or as profitable as we would like to be. And so we hope that what we have here today will definitely be of benefit to you guys and that you'll enjoy today's presentation. So I'm going to introduce the problem. So as you'll see up here, the growth of the human population, right? About the time of the Industrial Revolution is when we really started to see an increase in our population globally. And with global population increasing, this is what we're seeing. Our planet's resources that are needed for food are limited and perhaps overused in many cases. Just a couple of quick statistics, and I'm going to try to go through these as quickly as I can so that we save time for the bulk of the presentation. You can see up there the amount of resources that we use to feed ourselves. 92% of fresh water is being used right now globally. That's a lot of water, especially when we're suffering from drought in this particular part of the country right now. So, the earth can only give us so much, right? It can only replenish itself so much, so quickly, to meet the expanding needs that we have as humans. Right now, there's about 7.2 billion people on the earth, and we are utilizing 1.6 times, we consume about 1.6 times the amount of natural resources that are available to us. That doesn't even account for the projected population growth by 2050 that will reach 10 billion people. So we've got some issues that we're facing as agriculture producers. So the future of the animal industry, I'll quickly go through this. There's 4 things that we are looking at. Non-traditional feeds, different ways of feeding animals to meet their nutrient requirements, to be able to provide us with meat and milk. Regenerative methods. We want to be regenerative in how we approach taking care of the natural resources and those things that we've been trusted with as stewards. Animal welfare, that's big to us. How are we taking care of our animals? How are we treating them? Are we caring for them in a way that allows them to produce up to their genetic potential? And then technological innovations, which we'll get into. So that's a little bit about the problem and what is our solution. So we have an innovative technological approach to help alleviate some of the issues in the feed supply fluctuations. I'm from Juab County, and as I drove down through Sevier County here several times the last couple of weeks, it looks like you guys may have only got, maybe a first crop, luckily, this year. I talked to a few of you that said you were lucky to get a second crop. So we know that we have fluctuations, right, depending on the year and how much feed we're actually able to produce to take care of our animals. So we want to be innovative in how we approach the feed industry. We want to look for ways to utilize technology that will allow us to be more consistent in how we produce feed for our animals. And it's important that when you're utilizing and implementing innovative technology, that it's simple, right? I'm just a resident redneck from Juab County, and if it's not simple, I'm going to break it, right? I didn't even know how to turn this projector on. I was super glad we had Greg here with us today. I was calling everything a thing, and the only thing I called semi-correct was this right here. It's a clicker to me. I don't know what the real word is, but it's got to be simple. And then finally, it's got to be cost effective. We've got to be profitable as agriculture producers if we're going to maintain our relevance. And so being cost effective is important. Show you guys a quick video to kind of introduce our approach to this.
Nearly 2,000 acres of arable farmland are consumed by development each day in the United States. That's over 700,000 acres of land each year that won't be used to meet the massive agricultural needs across the world. In addition to that, almost 2/3 of the United States is abnormally dry, or worse, projected to be in a drought this year, which reduces the efficacy of pesticides and herbicides and cripples farm output and feed quality. Our solution to these problems? The self-contained, fully automated, shippable hydroponic barley fodder system that can match the yearly feed output of a 50-acre field of hay. It sits on all of 360 square feet of ground and doesn't need a foundation, building, or complicated maintenance. It represents dozens of tractor hours, thousands of gallons of fuel consumption, endless watering cycles, and broadcast applications of pesticides, fertilizers, and herbicides, all packed into a box that uses nothing more than 200 gallons of recycled water, barley seed, and ultraviolet light to create 2,000 pounds of feed per day, every day, rain or shine, with zero loss to feed quality. The animals love it, the environment loves it, and you will love it.
All right. So, real quick, the only thing that is constant in life is change, right? So our first system that you saw there was designed and created to be able to produce about 2,000 pounds of feed per day. In between us getting ready for this, you've all got a handout there in front of you that kind of outlines the specs of the system that we were producing. We've since changed and made some modifications and figured out how to increase the output of our system. We've simplified some things on it as well to make it a little bit more simple, as I alluded to earlier. And we're now capable of producing 3,000 pounds of feed out of that same square footage inside of a shipping container. And we've also evolved to be able to develop some systems that are a little bit more scalable for those of you that are a little bit more on the larger scale and needing a bit more feed than what one of these systems will produce. So that is our solution to the feed industry and some of the complications and issues that are out there with being able to provide your animals with enough quality forage on a consistent basis. The process all occurs in 6 days. So from 6 days from seed to harvest, our box is capable of producing 3,000 pounds of feed with 3 ingredients: seed, water, and light. And I'll add kind of a fourth to that is being able to control the environment and making sure that you've got proper temperature, airflow, etc., to be able to set yourself up for success. And I'm not going to touch on these too much because we're going to go into this in depth as we talk more. But the purpose of this is to allow us to have reliable production, improved efficiency with our animals and how they utilize their feed. It allows us to spare some land for those that are maybe feeling the urban sprawl creeping up on them. Or if you have desires to expand a little bit, it allows you to be able to do that. And then we're able to minimize the amount of natural resources to be able to produce this much feed. So with that being said, I'm just going to quickly introduce today's presenters. I have the opportunity on a daily basis to rub shoulders with these 3 gentlemen. They're all doctors. I'm just the resident redneck, but I tease and I say that I'm getting a PhD just by being around them every day. So at some point, I'm going to ask for my honorary doctorate degree. So today we're going to hear first from Dr. Brady Carter. He's a senior plant scientist with Renaissance Ag. Following his remarks, he's going to talk to us a little about why we sprout, the purpose of that, to help you understand that. After that, we will hear from Dr. Rob Harding. Dr. Harding, it took us several months to twist Dr. Harding's arm into coming and joining us. He wasn't a big believer at first, right, Dr. Harding? But after he's done his own research, he's a vet by trade and has an extensive background in nutrition as well. But after working on Dr. Harding for several months, he decided that this was a good spot for him. And so we were glad that he was able to join us, and he brings a wealth of experience and knowledge related to ruminant animals and how their feed works with them from a production and efficiency point. We'll hear from him after Dr. Carter. And then our final speaker will be Dr. Sanjeewa Ranathunga. Did I say it right? Yes. I've been practicing. Dr. Sanjeewa is our senior animal scientist, and this guy keeps us all organized, and he doesn't let us deviate one bit. Our goal here is to understand what is the truth of the product that we produce And Dr. Sanjeewa does a very good job of keeping us in line and helping us stay on track. So without further introduction, I'm going to turn the time over to Dr. Brady Carter. Do a quick mic change.
Okay. Hello, everybody, and I'm glad to be able to join with you. I'm actually from Morgan County, up in northern part of Utah. If you're from Richfield, you probably know Morgan because we always play sports. The high schools play sports together. But I want to talk a little bit about what row? There we go. Why we sprout. One of the things to know right up front about this process is that obviously in order to be able to produce sprouted fodder, you got to start with seed. And so that's the first main ingredient. And there is, in the world of feed, and in your experience this may be true or not, there's a ton of focus on dry matter. What is the dry matter that's the percent dry matter? What is the dry matter that's being fed to the animals? And so one of the areas where this starts to, has even been published to show that hydroponic fodder doesn't work, is the concept or idea that if you compare the dry matter of grain versus the dry matter of sprouted fodder, it's less. So there's going to be less dry matter in sprouted fodder. And so then the question is, well, why don't you just feed them grain? You're going to get more dry matter in that. So why take the extra step and go through the process of producing or sprouting fodder and not just feed them the grain? Now, from a sort of intuitive standpoint, that may not make, or it may immediately put up a red flag of feeding straight grain to animals. And most of us intuitively think that if we're able to put the animals out on pasture and have them feed on pasture grass, that there's an advantage to being able to do that. And there's a benefit to the animals. But then when we start to get on just a pure dry matter thinking in terms of this feed, then it starts to kind of fall apart because, again, you're going to get more dry matter into the animals if you feed them grain. So then why would we go through this process? And to understand why it's important to go through the sprouting process, we need to start at the seed. And seeds are pretty amazing when you think about it. They are the most efficient portable biorefinery that exists. Within that seed is the capability to create an entire new plant. And it has everything that it needs in order to be able to do that. And that's why it's structured from an evolutionary standpoint and an ecological standpoint the way that it is. So if we look at a grain of wheat, this is wheat. Barley is very similar. Most types of grains are very similar in the way that they function. There are certain parts to this seed. And each one of them has a very specific purpose. So on the outside of these seeds, there's something we call the bran. And this bran houses not only a protective covering for the seed to protect it as well as prevent it from germinating. Because you don't want your seed to germinate until it has the resources that it needs in order to successfully germinate. And that primary need is water. So it's not going to germinate until there's enough water and energy of water around the seed to be able to penetrate this bran and get into the interior. When that happens, the bran also houses most of the things that are needed to initiate germination. Inside of there, we have what's called the endosperm. And the endosperm is the storage chamber for the seed. It's where it stores its energy and the energy output that it's going to need in order to go through the germination process. And it stores it primarily in the form of starch. Starch is a very big carbohydrate granule that consists of glucose molecules linked up in chains. Those glucose molecules are the basic input that we need in order for us to go through metabolism. So every time that we go through metabolism, breathe, and produce energy in our bodies, we're using glucose as the main piece of that. And so the starch that's in this endosperm eventually is going to become the energy source for the germinating seed. And then the last piece is the germ. And the germ is essentially the baby plant that's inside of this seed. It's its own plant capable of being able to initiate metabolism and go through the processes that it needs to initiate growth. So housed within this very simple, very small seed is everything that's needed in order for this to be able to germinate and produce another plant. So why is that important in terms of sprouted fodder? So in this process, we start out with a seed. The seed is going to go through the initial stages of germination. It sticks out a radicle, the root that starts to move down, and then the shoot eventually comes out as well. And all of that you can see is coming outside of the seed. The seed breaks and expands apart. And eventually we get what we would call a sprout. So we've got a root system. We've got the initial cotyledons, are the first leaves that come out, and then you're going to get additional leaf coming out after that. Now during this time, the way that germination is initiated is that, as I mentioned earlier, there's got to be enough moisture present around the seed. It's something that we call water potential, and it works through osmosis or osmotic, where the water potential of the surrounding soil is high enough or higher than that of the interior of the seed, so that water will penetrate and move into through the coating. And so here we have that bran, that alurone that I was talking about is the outer portion. The green part right there is the germ, and then the interior part is the endosperm. Oh, there we go. So endosperm, bran or alurone layer, germ. So water comes into contact. It's of high enough potential in order to penetrate the seed. And when that happens, that water being present initiates the formation of gibberellic acid, which is a hormone. And the presence of that gibberellic acid then stimulates the production of enzymes within that alurone layer and releases those enzymes into the interior. Those enzymes are several different types, but the main ones are something called an amylase, which breaks down starch, and a protease, which breaks down protein. And so now these enzymes are going to start to break down this endosperm, the starch being broken down into glucose molecules, proteins being broken down into amino acids, that are then going to be essential for this germ to start to grow. So that those are broken down, the sugar, the amino acids are moved into the germ. The germ initiates metabolism and then starts cell differentiation, starts to produce its root, and starts to produce the shoot. That sprouting process, all of it being controlled ecologically by the plant itself and what it needs to do to survive. With these grains, these are annual crops, they're annual plants. So their whole purpose is to get germinated, grow, and produce more seed, because the only way that it's going to continue its species is by producing seed for the next year. So its whole purpose is just to be able to get that process going. What's important, though, is that in that process of doing that, it also produces all kinds of phytonutrients. It's producing amino acids. It's producing vitamins. All of these parts that is necessary for it to go through its metabolism also happen to be things that cattle need, sheep need, any kind of animal, and they're essential for their being able to function. In addition, it's breaking down starch. So here you'll see one of the big differences between feeding straight grain and feeding sprouted fodder. So the starch in grain is at about 63%. Grain is almost all starch. It's all that endosperm. That's what flour is. So when you grind that wheat and you isolate the endosperm and you produce flour, flour is almost all starch because you eliminate the bran and anything else that's not starch. So very high levels of starch in grain, very low levels of simple sugars. And then we get the reverse. So one of the things that the sprouting process does is transfer starch into sugar. And why is that important? When you feed grain to animals and it's all starch, it causes problems with their digestive system. Results in acidophilus, which basically causes problems within the cows. And the animal scientists will be able to explain that even better. But essentially what happens here is that you need to not feed straight starch to your animals. You need to feed simple sugars to your animals. So one of the things that the fodder does is breaks that down. In addition, notice the difference in protein. So there's a certain percentage of protein present in the grain. During the process of sprouting, amino acids are converted into proteins, as well as there being proteins broken down and produced and converted into other proteins. In addition, the digestibility of this fodder increases drastically from that of what you would have if you had grain. So the key elements of why it's important to go through the sprouting process and produce this fodder is, when it comes down to it, animal welfare. So even though you lose some dry matter in that process, the benefits that you gain by going through that process outweigh any kind of loss you would have in dry matter. And in reality, the feeding, the importance of what's being fed to animals isn't just that they get dry matter. It's that they get good dry matter or quality dry matter. And so all dry matter isn't equal. Certainly isn't equal. And so in this case, the reason why is to be able to make that transfer, to put it into some form of feed that becomes more digestible. The minerals, the vitamins are more easily sequestered when you go through the fodder process. What's also interesting, excuse me, is that these metabolites and phytonutrients that are produced during the sprouting process not only help the cattle, but they move their way through the cattle into the products that come from them or from the animals. So not only does that increase the phytonutrients in the animals themselves, but it also increases the amount of phytonutrients available in the food itself and the food that you partake. What's that? Oh, sorry. Got distracted. So the metabolites and phytonutrients that are coming from this sprouting process make their way through the food chain, which means that if you were to compare, and you probably heard, and maybe it's a bad word here, of this plant-based meat, right? Beyond Meat, that tries to show itself as being equivalent to meat, to true meat. And in fact, if you look at the nutritional profile of them, they are very similar. But that's because the nutritional profile that's normally on a label only includes very few of the things that are needed for our health and for our nutrition. What's not included on there are these phytonutrients and metabolites that can only be obtained through eating meat, because the cow or the whatever the animal is a biorefinery that takes those phytonutrients and metabolites from a form that's not digestible by us and puts them into a form that now is digestible and can be sequestered. So the only way to access these specific types of phytonutrients is by eating the meat of animals that have been fed sprouted fodder, whether that's pasture grass or whether that's sprouted fodder that comes from the system, the pasture box system. So what happens is that if you look at something, animals and products coming from animals that are fed straight grain, you start to see a lack of these specific phytochemicals and phytonutrients that are critical for our immune system, critical for normal growth and development, are lost if you were to go and consume just animals that have just been fed grain versus whether they've been fed grass and sprouted fodder. So when you think about this system, think about it as the fact that what it allows you to do is to feed your animals pasture grass all year long. So they can be fed in the pasture in the summer, and in the winter, you can now keep feeding them pasture grass. This is just sprouted fodder. It's essentially the same thing as what you would eat, or what an animal would eat if they were being pasture fed. And it's all about that sprouting process and what you can obtain from that that's critical to the reason why you would want to do that. Okay, I'll turn it over to Dr. Harden.
Thank you, Brady. I have learned so much about seeds and the sprouting process from Dr. Brady Carter. I really appreciate him. My purpose today is to talk about just some of the other benefits that come from feeding fodder, and we're going to get into things like economics and those kind of things. So here's just a little nutrient profile that just kind of compares. Brady went over this a little bit, so I won't spend too much time. But it shows you we have, compared to alfalfa hay, grass hay, and corn silage, we have a profile that's higher in crude protein, a little bit lower in fiber, but adequate, higher in sugar, lower in starch. You may see some different starch levels depending on the test and how well things sprouted. We'll have a little more or less starch levels. We have higher total digestible nutrients and a higher total digestibility of the fiber. And so these create some advantages that we'll talk about. Making those comparisons, if we compare the fibers, the NDFD30, we're comparable to a moderate corn silage and superior to most alfalfa hays. Our starch digestibility is comparable to corn silage and high moisture corn, but we're superior in total rumen efficiency, total digestible nutrients. How many nutrients can come out of that the animal can use? Palatability is another thing. We found that the sprouted microgreens are highly palatable. Animals will sort for them in a diet. And so if we're feeding it in a total mixed ration, we have to make sure that we have that mixed or ground, or they will sort for it. Brady talked about the phytonutrients and a little bit about metabolomics. This slide that Brady mentioned came from a researcher named Dr. Stefan Van Vliet. He has recently moved to the University of Utah, and we have partnered with him. He can measure those phytonutrients. He has a profile of about 1,500 of these individual nutrients and metabolites that he can measure, and we're measuring those on multiple sprouted feeds. And so we really like that. So this is just to show a little bit about its inclusion in a diet. The CNCPS is the Cornell Net Carbohydrate and Protein System. Basically, it's a model for predicting what feeds will do in cattle. It's how we balance diets now. It's the latest technological model for balancing diets, especially in dairy cattle. And so we used this model to put an inclusion of 10% of the dry matter of a diet of a high-producing dairy herd, and we compared some of these outputs. For example, the energy-corrected milk efficiency. This is how much energy-corrected milk can be produced per pound of feed in the diet, increased by 17%. It went from 1.39 to 1.62. The income over feed cost improved by 1.11%, but dollars, and that represented a 26% improvement in income over feed cost per day. This is how it did it. because of the increase in the total digestible nutrients, the animals were able to produce, or the model predicted they would produce, an equivalent amount of milk on less feed. So 7% drop in the amount of feed they had to eat to make the same amount of milk. We want to talk a little bit about when we produce these microgreens, the sprouted feed. The biggest input cost is the seed. And as we look at the way things have changed in the last year, the price of barley seed has gone from 202. This is a USDA average for the country, and different places in the country will have a different levels. We see wheat here at a 79% increase, corn, soybeans, alfalfa hay, and diesel fuel. So even though the cost of the seed has increased, so has everything else, and we're seeing that there's a relative rise, but what we're trying to do with Renaissance Ag is to make some partnerships where we can try to mitigate some of the cost of this seed. As more and more people adopt this, we'll understand that there will be more and more demand for seed. And so in some of our partnerships, we're working with some producers who will help us source seed and have that available to people who adopt this system. We're also really encouraged that we're partnering with people who are using regenerative agriculture practices and trying to help. We're doing some study and research right now on the quality of seed can make a difference in our sprouts and the nutrition as well, as we find mineral and nutrient-rich areas of the country to produce seed. We'll have better seed and better feed. Here's something else that's interesting. We had an economist that we're working with who coined this phrase of feed diversity. When Dr. Carter was mentioning the monoculture system where we feed basically one feed or two feeds, we lose a lot of that those phytonutrients and that biodiversity. But this sprouting system will have the capability for us to sprout multiple types of seeds. And as we find out these nutrient and phytonutrient profiles, we can make a seed profile or a seed mix that can be custom to your farm, what you're trying to accomplish. We have sprouted each one of these different seed types and about 7 or 8 more in addition to this. And we now have nutrient profiles where we can develop these multiple cultures. And so we've kind of gone through a lot of nutrient profile already, but I just wanted to show a couple more things about where we see some benefits. So Dr. Carter talked a lot about the sugars in these plants, in these sprouts, and we also look at these total digestible nutrients. There's the real advantages. And this is a high energy feed, and it's a premium feed. So comparable to alfalfa hay or corn silage diets, we would be the premium or superior in especially energy to most of these feeds. Another thing that we're learning is feed flexibility. Feed flexibility means that when we suffer a drought year, have a hail, and we need to still feed our animals, that having another source of feed and being able to be flexible and move into that when we lose a crop of alfalfa hay, having another source of feed can be a benefit to us and not have all our eggs in one feed basket. Some people have expressed a concern about the amount of sugar in the diet. Is that healthy for animals, particularly cattle? And so here's some things that we've learned, that sugar does not drop the rumen pH like starch does. Dr. Carter mentioned acidosis. It's a big problem in dairy cattle and feedlot cattle that feed high grain diets. And it causes a lot of health problems. But sugar does not drop the pH in the stomach of the cow like starch does. What we find also is that it also optimizes fiber digestion. So by including more sugar in your diet, you're going to get more digestion from the other things in the diet. So your hay will be digested better, the corn silage will be digested better because of this extra sugar in the diet. It also helps biohydrogenate trans fats. We've probably all heard of trans fats. They're not really good, and they cause problems in animals, particularly dairy cows, and it dings the butterfat production. So the additional sugar drives the rumen bacteria to biohydrogenate those fats and turn them into fats that are usable and maintain higher butterfats. So there's been 10 university studies now that have shown when you increase sugar in diets, you'll increase butterfat production, increase protein production, increase intake, and overall increase your fat-corrected milk. So it becomes a premium feed because the benefit of that sugar. It has the best response in high-producing cows. Next point, we're going over some things that, in addition to just the economics and the value, there's a whole bunch of other benefits that can come from feeding this. Organic, depending on the source of your seed, these sprouted feeds can fit into an organic system. We have a producer up in Canada who is going to use this pasture box system and market his milk as grass-fed, and that has given him a niche market to be able to market his milk in areas where there's a demand for grass-fed milk. Non-GMO, again, seed source can help us fit into those markets as well. We have come across people of every kind of production system you can imagine that are interested in this type of system, and including camels in the Middle East, rabbits down south, large sheep farming are very interested in the implementation of these of sprouted feed. We want to talk a little bit about feed efficiency and what that means. So feed efficiency in a dairy ration means basically the cow's ability to turn feed nutrients into milk or milk components. On a beef system, it would be the ability to take the energy from the diet, the pounds of feed, and turn it into pounds of meat production. But that's a feed efficiency. When we see this kind of thing coming through the manure of a cow, we know that's not a very efficient diet. And really what's happening there is we're just pouring money down the toilet because the feed that's coming out in the manure is not fully digested. And then what that does is it creates more and more waste that a producer has to deal with. By improving the feed efficiency of an animal with sprouted feeds, we have less of this and less manure to haul. Feed quality. I looked around the internet to try to find the best picture of shrink that I could find, and this was the picture. I grew up in southern Alberta, Canada, and we had a lot of deer up there, and would struggle with this sometimes. A lot of wheat is produced up there, and sometimes when a farmer didn't have enough storage, he would put the wheat on the ground, and if he wasn't able to haul that in and get it into market quick enough, it would be damaged by animals like this. But anytime we store feed, we're going to be faced with shrink. And so weather can have an impact as well. A hailstorm, a storm, a drought, wind, other things. Any time that we grow feed outside, it's going to run into these problems. When we store it, without a cover or without protection, everything on the face of that is going to lose quality. In fact, this was interesting. I found that when you store alfalfa hay, that 80% of the beta-carotene, which is a precursor to vitamin A, which is really important for all animals that metabolize, is lost during curing. And then about 7% per month happens during storage. And so a 6-month-old bale of grass hay will just have slightly more than 10% of the vitamin A left. And so whenever we store feed, we're going to face shrinkage problems and loss of nutrients. When we harvest brand new feed every day, those vitamins are there, and we don't have to face those shrinkage issues. So that's another huge benefit. I've been working in the animal agriculture industry for 30 plus years now, and I've seen multiple people try to use fodder systems. And this is the biggest problem that I've seen people have and trying to develop these, is the mold. Because of the high moisture that is usually in these systems, a lot of times people struggle with the mold and eventually go away from it because they can't control the mold. We feel now, with the studies and research that we've done and what other people have done as well, that we've figured out how to control this. And so it all comes down to environment and cleanliness. And so if we can control this, we can make a feed that's mold-free. No herbicides are needed. We don't have to control weeds in that controlled environment. We don't have to control pests in that environment. And there's no fertilizer needed in that sprout process. And so, again, more advantages with the sprouted feeds. About 4 or 5 months ago, I came across this article in the New York Times, and it said, "Meet the people who are trying to kill our planet." And it all came down to they're blaming animal agriculture for all the problems we have especially with global warming. A lot of the things that they said in this article were unfounded, but animal agriculture is receiving a lot of attention right now when it comes to greenhouse gases. But we know that farmers are innovative, and if you look at this, we've been improving efficiency in land use and feed use for 100 years. And now we use 90% less land and 65% less water for each glass of milk produced. And so this is another way that we can improve that efficiency and address some of those attacks that we're receiving. There's 3 ways that we can improve profitability on any production system. Number 1 is animal genetics. Number 2 is animal health and welfare. And that includes cow comfort, making sure that they're in the right environment. And number 3 is understanding how to feed them correctly. And when we can tune that in, then we can find that profitability. Land sparing and labor sparing. Up here, when agricultural producers were surveyed, 38% of them they all said that 38% of their problems with labor was finding qualified workers. So moving to an automated system, something that helps reduce labor, is another advantage. Land sparing. We're seeing this in Utah all over. I moved to Utah County because we wanted to live in a rural area when we moved here. And Utah County is not a rural area anymore. And we're seeing this all over. But going to a vertical agriculture type system can do is help us extend pasture. I found this picture on the internet where this is the last year this farmer will be doing this because he's totally encroached right there. But this is a real problem, and it's creating a problem with land shortage. Drought is becoming another issue, and the loss of farmland is affecting our food supply. We have again, this dairy farm that I mentioned up in Canada is going to use the pasture box system to help spare land that he has had into production and turn it into pasture. And so it will enable him to do that because he's growing some of it vertically. Water conservation. I wanted to spend some time on this. When I joined Renaissance Ag, they told me that their system could conserve 99%, would use 99% less water than a conventional growing system. And I didn't believe them. So I found this article also that 2022, the Utah Farm Bureau, the number one issue, state issue for the Farm Bureau is water issues. And we're finding that in northern Utah, they were calling for reduction in water this year. And we all know about tracking the reservoirs in Utah and the Great Salt Lake, the continued decline there. And this is the Ogallala Aquifer that goes from Wyoming all the way down to Texas. And these darker areas show the drop in that aquifer this year. And the blue shows where there's a little more fill in that aquifer, but we can see there's a lot more loss of water in that aquifer than there is fill. Anyway, I had to prove. And so Brady, Carter, and myself got in touch with one of his friends who's a producer. We did the calculations of the water use for growing an acre of alfalfa hay, the tonnage that would come off that, and the water that would be used per acre. And then we did the calculations and compared that to a fodder system that uses 200 gallons of water a day. And we found out that we use 99% less water. This system that we use recycles the water, and so there's literally no runoff. And it's a very, very efficient system for water. So it was true. That we can grow feed with 99% less water. Okay, that's all I had for this section. We're going to turn the time now over to Dr. Sanjeewa.
Thank you, Dr. Hatim, for a great talk. Thank you very much again being here. So my name is Sanjeewa, as Brady mentioned. So my role is to discuss what we are doing at Renaissance Ag to get this all nice data. Our research unit is called Microgreen Institute. So what we are trying to do here is that we try to generate data because we like to know how to grow fodder in using hydroponic system and how to feed them. And what are the benefits that we will get out of in the farms or to the environment. In that, what we try to do is that we try to create database. To do that, what we do is that we collect the already existing data, and then we try to find out the gaps that we need to fill. And then next step is that we try to search the truth. That is that fill in the gaps in the knowledge. So for that, what we do that we do like in-house research. So we have our own experimental unit. So right now we are developing that, and also we try to work with universities or different research institutes to generate the data, so that they can run their own research so that we know that those data are coming from independent sources. Right now, we are working with different universities, Cornell University, Utah State University, University of Wisconsin, UC Davis, University of Florida, and University of Guelph in Canada, and South Dakota State University. And also, I'd like to show you, as Renaissance Ag, what our future plans are. As of now, what we are doing is that we are growing, or we are producing hydroponically grown sprouts. We call them microgreens, using pasture boxes. So that's what we were talking about, during this talk. But this is not going to be limited, because what we are going to do in our mission is that we try to help the farmers to produce animal products in more sustainable way. So that what we are trying to do, that we are trying to start from the beginning, that is crop production, where we need seeds. So in that, what we are trying to do is that we try to use the regenerative ag practices. What is the meaning of the regenerative ag practices is that, right now, the way how we grow crops is that, we are using more synthetic fertilizers and herbicides and pesticides. So using these regenerative ag practices, we try to eliminate those or reduce the use, and then we try to keep more sustainable practices. And right now, as I mentioned, so we are learning how to do this in using controlled environment agriculture. And then other thing is, the main thing that we are looking at is now how to feed these sprouts to the animals. So in that, we will develop improved diet balancing programs and also nutrient management. Another aspect that we think that very important is that the manure management and animal waste management. This is a really critical issue around the globe, and there are ways to reduce the damage caused by this animal waste or manure, but there are no sustainable ways at the moment. So what we are trying to do is that we try to partnership with a company, and we are going to use the insect larva. So what we will do is that we let this larva to eat all the manure and also the processed waste. So what they will do, that this larva will consume this, and they will convert this waste and the manure into larva protein. And their excreta, we call them as frass. So this frass we can use as a fertilizers. And then this black soldier fly larva protein we can feed to the animals. So that what we are trying to do is that we can try to recycle all the nutrients within the farms. And by that, we try to reduce the environment pollution. That if you have a manure lagoon, or say that if you have a slaughterhouse, so you have to discard this waste into the environment, and that can pollute the environment. So by that, using this kind of technology, we try to avoid this problem. And also, I'd like to discuss, how we are going to feed the animals, because that's very important. That once we grow the hydroponic fodder, we need to know how to feed them. So we, as I mentioned, we are partnering with different universities, and we are using a 4-step experimental model. So in that, we use different methods. We call first one is the in vitro models. In that, we will not use animals. So we use basically the meaning is that using test tubes. We will do experiments in test tubes. For example, right now we are working with University of Florida, where they are using artificial rumens like this. So they ferment the feed inside these glass chambers, and then we can measure the forage digestibility in that. And there's another technique called in situ methods. So where we are using cannulated animals, where we try to create a hole in the left side of the animal, and then we can access to the rumen. So in that, what we do is that we incubate the feed inside the rumen, and we let it ferment, and then we can measure the digestibility of feed. And other method is that we directly feeding the live animals. So these are very common method. And right now we are working with Cornell University to feed dairy animals, so that we can measure the dry matter intake and also performance of the animals. And the last method is that the beta trials at the commercial animal farms. In that, what we do is that so the data that we generate from in vitro methods, in situ methods, in vivo methods, we will apply in the real under commercial farms. So, if you are happy that we would like to join with you, soon after we are done with some of the research, probably we will approach you guys. So if you are happy, that we would like to work with you so that we know that this technology is practically applicable. With that, so we'd like to conclude our presentation. And again, thank you very much for your presence here.
All right, guys. We'll open it up now. Does anybody have any questions about either of the presentations? Yes, go ahead. Okay. How do we do no mold? Dr. Harding, Dr. Sanjeeva, do you want to take this question or do you want me to? Go for it? Oh, that's dangerous. So the way that we mitigate mold in our system, like Dr. Harding alluded to over his career as a vet, he's seen a lot of people that have tried different fodder operations for a number of reasons, but they run into the issue with mold. We treat our water with ozone. I've only said it a million times over the last year, but we treat our water, we inject a small amount of ozone into the water, and that neutralizes the mold and the bacteria that could be prevalent and allow for mold to grow. The other thing that we have learned is it's super important to control the environment. The right temperature, the right amount of airflow is very crucial to being able to successfully grow a mold-free crop of fodder. Anything you want to add to that, Dr. Harding?
That's just about perfect. We're playing around a little bit right now with flood irrigating versus sprinkler irrigating, because we learned from Dr. Carter that the top of the plant really doesn't need moisture. It all comes through the root.
Do you want to add anything to that?
So we think that we can mitigate some of that mold from sprayer to flood irrigation that just have the roots taken up.
Thanks, Dr. Harding. Oh, follow-up. Correct.
And when it comes in.
Yeah, so the water is treated with ozone. When the fresh water comes into the system, it's treated with ozone. Anything that is not absorbed by the plant that we capture and reuse is also treated with ozone as well. Along with it goes through a series of filters as well. Brady, you might be more suitable to answer.
What was the question?
What is ozone?
Ozone is O3. It's oxygen there's three oxygens that are bonded together. But what it does is it interrupts the capability of the organisms to undergo metabolism, so they just don't grow. They aren't able to reproduce. The other key thing is with mold. Mold spores are ubiquitous, but if you can reduce the load of mold spores, the whole thing about mold growth is there's a couple of things that mold needs to grow. One is you need spores. Number two, you need a nutrient source. Number three, you need some water. And number four, you need the right temperature and pH, or 5 pH. So any of those things that you can interrupt slow down its growth. So if you were to take fodder and put it in this pasture box and let it sit there forever, it's going to mold. It just will, because there's going to be mold spores there. If you were to clean seed inside of that container with it, you'd have a whole lot more mold because you're bringing in mold spores with your grain. If you control the temperature to a lower temperature than, say, at 70 degrees versus 80 degrees, at 80 degrees, mold grows really fast. At 70 degrees, it slows it down enough that you don't see mold when you're done with the 7-day growth. So it's all about timing and preventing those things from happening, not that you can completely eliminate mold, because that's impossible.
Back there.
Do you guys pH your water?
question was, do we pH our water?
Yeah, we've done some experimentation with controlling the pH of the water. It actually doesn't have a huge effect on the growth of the fodder itself. So the optimal pH for the water, according to or based on our research, is a little bit acidic at about 6, pH of 6.
What about cleaning? Do you clean seed as well?
Yeah, the seed gets cleaned, and in its optimal form, the seed cleaning process will happen separate from the box. So there'll be a seed cleaning, and that process will happen, and the seed will be funneled over into the box and will be clean at that point already.
So when you guys store your seed, it's clean, pre-cleaned. It's not soaked, it's just clean.
Right.
Yep.
Yeah, you don't want to get it wet until it's inside the box.
And you want to keep the seed cleaner separate from the growing operation. Other questions? Go ahead, back here.
Have you done any comparable studies with, for instance, profit production of alfalfa versus actually selling? We have 250. I'm selling for $400. So that's way off. But have you done any comparative? This is the cost of production of hay. This is good quality, relative feed value, dairy quality hay compared to this forage. And the inputs and the outputs, and is it cost effective for someone to put these in? What I mean, I understand some of the things you don't have to trap, you don't have to be out, and all those things out there, less water. But put that in a perspective for someone who wants to invest in this, and wants to return on investment. You've done that.
Does everybody hear his question?
Brady.
What we've done. Oh, I thought you were going to talk. This is a question for you, Doctor.
I'll just repeat the question. He was asking to do like a cost comparable, right? If we're comparing this to alfalfa hay. He's selling his alfalfa hay for about $400 a ton, and we know that hay prices are going up, and that they'll continue to go up. But he was asking for a comparable, right? Have we done some comparables as far as cost and some of the economics behind feeding sprouted fodder, whether that's sprouted barley or sprouted wheat, in comparison to just straight alfalfa?
Yes, we have done some of that. So when we figured the cost per ton to produce that, sprouted feed will always come out a little higher. So today, with alfalfa hay at $400 a ton, sprouted barley feed on a per ton basis would be less because it's a lot more moisture. But if you dried it both down and compared it on a dry matter basis, sprouted barley fodder would probably be a little bit more. But because of the added benefits, right now the trial that we're doing at Utah State University is teaching us some things that we feel that you can actually feed less feed and get the same production out of the animal unit. It actually becomes an economic value, economic benefit, where we can, there's more value in it than the straight alfalfa. So it's always going to come out higher on a pound-per-pound basis, on the dry matter basis, but when you put it into a feeding operation, it can be more economical than feeding high-quality alfalfa hay.
Well, the cost for dry matter is always going to be higher than producing the hay.
Well, it depends on the year.
Yep.
It depends on the year. Right now,
Based on today.
yeah. Oh, today?
At $400 a ton, you're pretty comparable, right?
Yeah, we're pretty comparable right now. We're probably 460, 470 on a dry matter ton, where you'd probably be about 425, 430 on a dry matter ton of alfalfa hay. And so we're pretty close right now. And that includes the capital expenditure too, included.
So what's the price of barley? What are you figuring the price of barley?
Right now, we're figuring the price of barley seed at, let me calculate that.
What do you have it as a ton, 269?
Yeah, $269 a ton. Or
That's 14 cents. It's more than that.
yeah,
more
I
like-
think it's
more
more
like
than
30
that
cents.
now. We're about 25, 26 cents a pound for barley seed.
The last barley we bought, I think we paid 26 cents a pound.
Yeah.
So did everybody hear the question?
The question was, how much power does it use?
How much power does it use? I believe it's on our handout. I don't remember right off the top of my head. You flip this over to the back side. It's got some of the specifications there. We are using about 3.5 kilowatt hours of power per day to run a system. So it's relatively very efficient in its power consumption as well. Good question. Other questions?
What do you use to clean your seed?
What do we use to clean our seed?
So we, right now, we're sending all of our seed to Leland Mills, and they're running it through their seed cleaning process. We currently aren't set up to clean our own seed, but we have worked out an agreement with Leland to make sure that all of our seed is cleaned properly and ran through their system to get it clean.
Does that help clean out the mold spores?
Brady, I'm going to have you answer this. The question was, running it through a cleaner, does that help eliminate and remove the mold spores?
Yeah, it does depend a little bit on what method they're using for seed cleaning, but certainly it does reduce the amount, because a lot of the mold spores are held in the dust and the dirt that's on the seed, which then gets eliminated through the filtering system or through blowing. But if you pipe that stuff that's coming off your seed cleaning into your area where you're growing your fodder, you'll get lots and lots of mold.
Good question.
Question in the back.
All right, one of these pasture bought 3,000. When you buy one and you start operating it, is it like buying another herd of milk cows in 10? Or how much labor does it take?
I take it from that you've milked a few cows in your days.
Yeah, I got a water bottle.
So the question was, if when he buys one of these, is it going to be like buying another herd of dairy cows? Is he going to be married to it? And to answer that question, no. The point and the purpose of the innovation and the technology that we've incorporated into this allows you to not have to tend this thing on a 24/7 basis, right? The automation is set up to take care of the labor behind this for you. Now, you're still going to have to do some maintenance. You're going to have to be there when it's set to harvest, things like that. But the idea is to eliminate labor and allow you to be able to move away from it and not have to babysit it all day.
One more question. When this water is about this high, or this high, which has got the most protein to feed it?
Dr. Hardy, you want to answer this? Did you hear what he said?
Yeah, I did.
Okay.
Brady might be able to answer this better than me, but actually the 6 to 7 day growth has the best nutrient profile. After that, it dips a little bit, and then it'll come back up a little. But that 6 to 7 day harvest is going to be your optimum.
So it eats the roots, the white and the bottom after so many days, and that's where you lose some of your protein.
We're actually gaining protein from the seed. We follow this sprouting process from day 1 all the way up to day 10. Now, we've done serial nutrient profiles on seeds at different days, and that seed starts out at 10 to 12% protein, and then it goes up to that 16 to 19% protein. We'll take a little dip. Is that correct, Brady? Yeah.
Yeah, after day 7, it starts to reallocate protein as it tries to prepare to start photosynthesis. In the first 10 days of growth, there is no photosynthesis in these plants.
Another question.
I know I'm full of questions.
Keep going.
When you feed
I think the reason people are recommending feeding a dry product with it is because it is so digestible that on a cow it'd be like turning it out on fresh green grass. It's just going to go right through them. And so, yep, that's correct. Yeah, so they need some scratch factor, something to slow that rumen, that digestive process down, so they get the maximum utilization of all those nutrients. And so right now, optimally, we love to have it be a complete feed, but we know right now, or the way we understand the digestion of animals is, especially ruminant animals, is that they have a certain dietary fiber requirement and an effective fiber requirement, so they do need some dry fiber with it.
Take that mold, feed it in your pig.
Well, and Dr. Harry mentioned. And one important thing, the reason why mold is a problem is it can be a problem is mostly because of mycotoxins, which can be very detrimental and even lethal at times. One thing to keep in mind is just because there's mold there doesn't mean there's mycotoxin. And in fact, when this is grown with mold, it's been tested, we've tested it, and there are no high levels of mycotoxins in it. So even if you got mold and they eat it, it's not going to be dangerous. It's only dangerous if there's mycotoxin production, and that happens. You got to have a lot of mold before it starts to produce mycotoxins.
Good question. Thank you. Got one right here, Rick?
Yeah. You said that photosynthesis doesn't occur with wood process. Why do you need the LED light?
That's a really good So, a very good question. The question was, if photosynthesis doesn't occur, why do you need light? It won't be green. is the easiest answer. If you don't give it light, the chlorophyll won't form and it won't turn green. But it doesn't add to the dry matter at all. It doesn't change the profile. So you could essentially grow without light. Now, the one thing that there is some difference in is beta-carotene levels. We've seen some optimization of beta-carotene if you do certain types of lighting. And that's still research that's ongoing where you could then impact the vitamin A levels by what light you have. But in terms of dry matter production and fresh matter production, the lighting doesn't have any effect.
Make it look pretty.
Yeah, it makes it look green. Yeah, and maybe more appealing.
It's like a well-done steak versus a medium rare.
They'll eat it if it's yellow.
Go ahead, Dina.
So, questioning on the lighting. So, if you are using lighting purpose to go ahead and get the chlorophyll to the green and before it gets into the photosynthesis, can't you use a cleaning light? You know, like everybody's starting to go use ultraviolet light to go ahead and keep the mold down. Will that interfere with the plant vegetation or?
Mixed results on UV application. There's a lot of, in the whole world of hydroponic and controlled environment agriculture, one of the main areas for research right now is lighting. And in crops like lettuce, hydroponic lettuce, for example, photosynthesis is occurring in that kind of a crop. So it's unique in this 6-stage fodder that there's no photosynthesis. And when you do get into photosynthesis, then the light wavelengths become very important. And part of that research is application of UV light at certain times to enhance disease protection and other actual benefits coming from the UV light. Now, in terms of using UV light to kill organisms, you certainly could do that and it could have some benefits. The question is the cost benefit versus how much it costs to apply UV lights. So there is a cost associated with lighting. Obviously, as you get to more complex LED lights that are trying to put out wavelengths across the entire range, the expense goes up drastically.
So how long can you keep this water that comes out from?
You mean how long can you store it after it's produced? Yeah, not very long.
What point does it nutrients dissipate?
Yeah, so this is not in its form right now, is not something you could store for any amount of time. It would mold and it will start to ferment.
because you are very, very high moisture with very active enzymes in there. So in order to be able to store it, you would have to do some sort of a densification process too. You'd have to dry it in order to store it for any amount of time.
What's the optimum time?
The day of or the next day.
Just a little anecdote, then we'll get to your question, and then your question. We've done multiple studies, multiple trials, tons of research and nutrient profiles, and we had some where we've done some harvests where we didn't have a place to go with the fodder, and so we set it just out on a concrete slab in the sun, and because of the moisture that was in the plant, it sat there for 2 to 3 days, and continued to grow. We didn't water it, and it was still beautiful looking fodder after 2 to 3 days. So it's not going to immediately spoil, but it depends on where you're putting it, where you're storing it. If it's in the sun where it can get some light and some heat and continue to grow, it'll continue to grow. So it doesn't spoil immediately, but if you just put it in a tub or in the dark, it will spoil. Yes, question here.
So would fermenting be a problem? That maybe be a
Fermenting? Yes. In fact, the partnership we have with University of Wisconsin is we're going to try to do a storage study where we ensilage and try to see if a production system. We're looking at have a lot of beef producers who say, I put my cattle out on range all summer, and then what do I do with my pasture box while they're out on range? If we have a way that we can ensile that or store it, that would be an advantage. So we're in the process of developing an ensiling study to help us learn how to do that. Yes. Well, right here first, and then you. To start with, yes. It will be more feed than it is included. In fact, right now we're doing a study with Utah State where we have a 50% included. So there's a range that can be 50 to 75, somewhere in there. We know that we have to add a little bit of fiber in there, but we know that range can be as high as 50 to 75%. Okay, the exchange rate. Okay. Well, what we're doing right now at Utah State is to prove a concept that some other people have tried to feed it pound for pound with alfalfa hay. But when you take into account the dry matter difference of alfalfa hay to the fodder, there's a huge difference in actual dry matter product there, but we're feeding it pound for pound. And right now at Utah State, we're about a third of the way into this study on beef cow-calf pairs. And it seems to be working beautifully where we can replace hay pound for pound on an as-fed basis. So we're feeding a 50% low-quality alfalfa hay and a 50% fodder and comparing it to 100% low-quality hay diet. So that's a reasonable way to approach it is just replace it pound for pound with hay. The increase in the total digestible nutrients and what it's going to do to the digestibility of that poor quality hay will make up for the difference in ground. I hope that makes sense. Yes. Okay. Interesting question. We had a little conversation earlier before the meeting started about pelleting process, drying and storing. So we have been in contact with another company who grows fodder on a high production basis and pellets and sells it as a horse feed. And they've been very, very successful at it. And they have customers who just claim that it shines those coats up. So we've taken their product, we tested it all through the process. We know that in order to pellet it, you have to squeeze all the moisture out. And so they press it. They grind it, they press it, and then they mix it with some dry feed, and they pellet it. And in that pelleting process, we noticed that they had some mold in some of their production. The pelleting process will kill all the mold. And then the second thing we learned was that a lot of nutrients come out in that water press. So you're going to lose some nutrition in the pressing of that, the water out of that fodder, but there still will be a really nutritious product that comes out in the pellet. But so we're looking at that. We haven't developed a system, but there is a system out. We can talk later if you want more information about this group that's already doing it. Yes. Rough cost of the pasture box. I should let Brady address this one. You want to talk about cost of the pasture box?
Sure. That's what everybody that was just kind of walking around the floor was asking. I think
I know we've been here for quite a while. We appreciate y'all sticking around. So cost, great question. As I introduced earlier, right, your brochure there's the Pasture Box 2000, and in the process of Greg putting all this material together for us, and this actual presentation, we already evolved as a company and have figured out how to make some changes to simplify the system and to get it to produce more with the within the confines of the container. And so because of that, we are offering these on a subscription service. Okay? So what that means is you pay a monthly subscription. We bring you a box with a companion silo box. We'll also provide the seed to you if you're interested in the seed. But the monthly cost on a pasture box and a silo box unit combined is $2,500 a month. And we're doing that because we know that the technology may continue to evolve, right? That we may find things that we want to change or improve on and make better. It's a very capital-intense piece of equipment, right? Comparable probably to a John Deere tractor or a combine. And so rather than you guys have to come up with the capital expense on your own, we will take that burden and we will build the system. We'll put the capital up. We'll get it built for you. We'll deliver it to you. You pay the shipping costs on getting it delivered to you. And then you subscribe to it on a month-to-month basis. And then the seed, I just want to make sure we understand ourselves here. The seed is in addition to that. We can offer you seed at whatever market price is at the time.
So this is $25, $50 per seed?
Correct. Yep. Except for seed. Yep.
So do you have options larger or smaller to the 2000?
Good question. The question was, do we have options larger or smaller than the Pasture Box 3000? So right now, the Pasture Box 3000 is the one that we're focused on, the one that we are building the most of right now. We are in the process of scaling a much larger system that could handle a large-scale dairy or a feedlot or a bigger beef outfit, something like that. And we are also in the process of building some smaller systems that would grow anywhere from like 150 pounds up to about 500 pounds a day. We haven't finished any of that stuff yet. We've built one and tested it and tried it, and learned a few things, but we haven't really made that a part of our business, but it will be on the smaller scale. And the larger scale systems are actually underway. We're in the process of getting one built as we speak. Other questions? So the question was, does the system include the seed cleaner? The answer is no. We haven't gotten into providing seed cleaners, but the seed that we will provide you is clean. And we have grown that seed ourselves, and we know that that seed is quality seed and works well in the system. Did you have a question? Or where was it? Back here.
I missed the first part.
Okay.
How often does the system water on a daily basis?
So it's set up to water once every, what's the new watering cycle on that?
I think it's every hour, every 58 minutes.
Every 58 minutes. So it waters for 2 minutes, and then it's off for 58 minutes, and then it waters. Yep. And we're learning a lot about water right now, and the amount of water, the duration, the frequency, those type of things.
And now it's overhead, or is that it?
So right now, that was overhead. Everything that we're using right now is overhead, so spray. But we are in the process right now. Dr. Sanjeewa is really involved with this. We're looking at different methods of water. What's the best way to water, right? Like a flood. Yeah, there's potential for that. Yep. So that's some of the stuff that we're in the process of doing right now. Testing is what's the best way to water, what's the best system to utilize, how are we going to optimize the water that we have available to us even greater, right? We know compared to traditional farming that we're able to use 99% less water, but we want to make sure that within the confines of that box that we're also being very efficient in optimizing it.
So with the overhead spraying, because obviously if you have humidity and constantly increasing all, so if the flood irrigation didn't allow that precipitation loss to get really humidity to cause, so the system that I was telling you earlier, mine was flooded and it worked great. And the reason we went to that is because the precipitation value.
Okay. No, that makes sense. And that's something that we're in the process of testing and trying ourselves. Did you want to add something to that, Dr. Hardy?
I was just going to mention that this system is all 100% programmable too. So on that little pad that you saw on the pasture box, you can program how many times you want to water a day, how much water you want to do per time. You can program how much seed depth you want. You can program when you want it to harvest. If you feed twice a day, you can program it to harvest half the day's harvest in the morning, half the day's harvest in the afternoon. So it makes it flexible to fit into your production system and gives you all the flexibility that you want in planting, harvesting, watering, everything. So we tried to make it simple so that it can fit in just about everywhere.
I'm not sure exactly how to ask this, but all of the systems that are coming out of wells or culinary water that's coming out of like the city system with chlorine, any difference in that?
Brady, do you want to handle that one?
Yeah, it's also true of the reclaimed water. When you reclaim water from in there, it changes. Mineral content goes up because obviously some of that's sloughed off during the watering process as it goes through the root mats. So yeah, it can have some impact on the proximate analysis. We've even toyed with the idea. There's a push to try and start using gray water for irrigation. To try and be able to have a way to be able to utilize that. There's a lot of problems that come with that because one study I saw was looking at just one type of pharmaceutical that was now being built up because of reusing gray water. But certainly if you're coming from a well versus you're coming from a city water, there can be some slight differences in what those are. And typically that will translate into a little bit different approximate analysis. And mainly in minerals. So you can have a little bit higher calcium, a little bit higher chloride. Sometimes that's good, sometimes it's not. And it's another area we are researching is whether we can dose the water and actually change the mineral content of the fodder itself by adding minerals.
Like, have you ever tried colloidal silver to keep the mold down?
I mean, we haven't. I mean, it's it's an interesting concept as far as being an antimicrobial, but again, we don't want it even to grow. I mean, in terms of treating the water with it, there might be a possibility, but the mold spores aren't really coming from the water. They're coming from because they're in there. And then the watering that's happening in terms of the water is what encourages its growth by humidity. It is. Yeah, HVAC control as well as airflow control. That helps to remember the temperature is critical. So one of the most important things about getting good growth is to maintain a temperature at around 72 degrees Fahrenheit. That's the optimal place for growth of the plant, plus it slows the mold down.
Plus it's insulated, so it can run 365 days a year. It's rated down to, I think, minus 20 to over 100. But we have people who, if they're going to put it in a TMR wagon will cut them mostly up into maybe there'll be some chunks about that big, and they will sort through that a little bit. But if you want it perfectly balanced in a TMR, we can add a chopper to it. And then we have other places that just feed it as fed. They just put the biscuit out, and the animals will eat it. We have a goat dairy that's doing that. We have some beef producers that are feeding it as fed, just in the biscuit, and then they feed the rest of their diet in another bunk in a different form.
A vertical mixer mixes it up pretty well. Like Dr. Harding mentioned, we're in the middle of a trial right now at Utah State, cow-calf trial, and they just mix it, about 5-10 minutes longer than they normally would. And it's blended and mixed beautifully. If you want to see pictures of it, I can send it to you. It's really mixed well.
Eliminates your need for water in the TMR too.
Yeah.
Yeah, I took some videos. It was interesting when they had the vertical mix running. They put some hay in it, spun it. I mean, it was just a cloud of dust, right? And I don't like dust, so I was hacking and sneezing. And then they dumped the fodder in and spun it more, and it just eliminated the dust. So it adds some moisture to some dry feeds that makes it a lot more palatable for the animals.
So, off of mine, because I did horses, and I had a hay donor, and what I found the best of this is when they were doing the fodder, they weren't dumping the hay and killing which don't have as much loss because they're kicking it around, getting it in the dirt.
Minimizing waste.
Yeah.
Cool. That's a cool observation. Thanks for sharing that. Other questions?
Question right here.
Go ahead,
So
Steve.
you first started out, you weren't on fodder. What changed your mind? What changed? How much they were paying?
Everybody hear what?
Yeah, it was my paycheck. No.
Why wasn't he a believer at first?
I wasn't a believer because of the mold. It wasn't because of the quality of the feed, because I could see value in that. And I'd received a bunch of tests. People said, "Hey, Doc, what do you think about this?" And I said, "It looks good." But the more they tried to do it on their own, they're usually just rack and stack systems in a building, and they couldn't control the environment. They couldn't control the humidity, and mold took over. And once some of those spores get in a building that can't really be cleaned, then it's hard to get it out. And so everybody that I'd looked at had gone away from it because of mold. But once we figured out that we can control the mold, then I became a big supporter and a believer in it. So I've always believed that it was a premium feed, and that animals, these grazing animals, are designed to eat grass. It fits into their diets so well because their bodies have developed to digest that in that way. And so I've always liked the feed. It's just the mold control that was always my hang-up, because I saw probably a dozen people try it and go away from it because of mold. Does that answer your question?
Yes, totally. So what are, and maybe you've already covered this, so I apologize, I had to step out for a minute, but what are some of the ways you are controlling?
Okay, we did discuss that a little bit, but I'll just review them again. Number one, I think, and there might be others that put others first, but I think that environment control is number one, the temperature. In some of our studies, we had a breaker go out one day, and the temperature in our box went to almost 100 degrees, and we had a ton of mold. But when we could keep that box to between 68 and 72 degrees, then we almost had no mold at all, or none that we could see. Because like Brady's comment, it's always going to be there. You're always going to deal with spores, but can you see visible mold growth? The second thing is cleanliness. So on some of our semi-automatic systems, we call them, where we manually seed and harvest, we try to clean those trays. And in our pasture box here, we have a pretty strong jet spray that cleans those trays as they turn over, and we try to keep the trays as clean as possible. I think that's number two. And then the ozone system, we use ozone, inject the water with ozone, and I think that has had a really positive effect as well. So those three things, I think, have enabled us to really control it. In the bigger systems that we're looking at, the biggest challenge is going to be environment control. Because in a building this size, the temperature up there is going to be different than the temperature down here. And so the beauty of this little pasture box is it's contained enough that we can really do a good job of controlling that environment. But the bigger systems are going to present a little bit more of a challenge. Any other questions? Well, I think it's been great to visit with you. Appreciate all your questions. They were great questions. We'll hang around here a little bit longer if anybody wants to talk to us individually, but I think we're done the Q&A for now. But thanks everybody for your attendance. It's been really great to be with you today.